everybody, and welcome to another exciting, fun-filled, expeditious episode of Radiorama, where, as the name implies, I show you how to work on radios and other things that tend to run on glowing vacuum tubes from the 1930s through about the 1960s. And today we have a 1951 through 1953 Hallicrafters Continental 5R30 in the very much less common, I'm not sure what you'd say, like chalkboard black finish. And yes, this is the original finish. And a lot of people chose not to buy this. They came with a variety of very cool colors. Quite a surprising variety. I've seen them in white, my voice is cracking, sorry, white, black, coral, green, and blue. I've even seen these with a clock built in, but it's kind of an iconic design, very clean, very modern looking. Hallicrafters didn't make a lot of consumer radios. Well, I did, but they didn't make a lot of like regular household radios. They were big into ham radios for ham radio hobbyists. And sometime in the 30s, they bought another radio manufacturer, and I can't remember what that company was, but it doesn't really matter. But they used that to make essentially their home radios, and this is one of them. This is going to be part 2 of a series that I started a while back, which is the very basics of how to restore a radio. And I wanted to make an example of one of the most common sets that are out there from an electronic design perspective. In particular, if you're American. Now, if you're European, chances are that most of your sets came with a power transformer. Anyway, these are called, as I mentioned, the All-American 5. They call it that because they tend to come with 5 tubes. The other thing is that they don't have a power transformer. Instead, this is a filament string series, and so all of the filaments are strung together like an old set of Christmas lights. And the way it works is very similar. So if you have an old set of Christmas lights where they're only one string, and it's just like a filament string like this is, the voltage that it takes to light each bulb might only be a couple volts, like maybe 6 volts or something. But if you string them all together, all of their required voltages together is going to equal 110. So you can do that. So same is true with this radio. You can string all the filaments together by their voltages. So you can see here on that tube, this is the rectifier, and it says 35Z5. This one probably says 50L6. So what does that get? And I'm not a mathematician, so 50, 60, 70, 50, 60, 70, 80, 85 volts right there. And so we need an additional 15. And so we have a 12 here, 12 volt here, 12 volt here. You add that, and it's more than enough to equal 110 volts. I had to stop because my wife can't get the lid off the jar. So, you proud? Right. All right, let's continue on since I was rudely interrupted. Anyway, it's my wife. She's very sweet, and I love her. We've been together for almost 20 years. Now, where was I going with this? Okay, so not having these all strung together means you don't have to put a power transformer in it. And that saves a lot of money. It's a more simple design, but it comes with some drawbacks. And one of the biggest drawbacks is safety. And there is less safety in this design than there is from a power transformer set. And the reason is because if you're going to run all of your filaments together, and that means that one end of the power line equals one end of the filament string versus the other, then that means you need to complete the loop, right? And since we don't have a power transformer to do that, that means that it needs to go somewhere, and that somewhere is that metal chassis. That is the ground for the other side of all of these filaments stuck together. That creates a problem, because if I, the unwary consumer, I don't know, was in the kitchen and I reached around here, and granted this did have a back on it, but if I were to touch that and I don't know, touch the faucet or something at the same time, I'd get a jolt. Now, some radios are more dangerous than others, and I know from experience of working on this model many times that this is one of the lesser dangerous sets. And how they accomplished making it a safer set was they would put a capacitor between the other side of the AC line and the chassis. And so that would reduce the amount of current that could potentially get there. Now, if you just made it straight hot chassis, and some sets are like that, then you could really electrocute yourself. And there's some sets I've seen, especially a lot of weird ones from the 30s, but even some dating up to the 50s, where they are just grossly and a very hot chassis set with not a lot of protection from the consumer. And that said, a lot of people wouldn't choose to, touch that and ground. So there's a big difference. And the reason that we're going to work on this AA5 is because it is such a common design that it's a good way to kind of learn the ABCs of restoring a radio. Now, there's some safety considerations when it comes to working on these. And depending on how you row or how experienced you are is going to determine your opinion about what you think is safety. But if you're going to be in this hobby, bare minimum, you should have something like this. This is a isolated variac output transformer, meaning I can adjust the voltages from 0 all the way up to 150. And from an electrical perspective, it will make sure that I will not become the ground. It will be the ground. And so that saves you from jolting yourself. The other thing it does is it'll let me monitor how much current that the set's going to draw. It's less important on a 5-tube radio like this without a power transformer, and more important for radios like this that do have one, because if there's something funny going on and something that's directly shorted in line of the power transformer, you'll want to know it, and this will tell you if something funny is going on so you can stop before you self-destruct something. On these guys, the worst that'll happen is that the weakest link in the chain is going to fail, and that usually means there's a little 1/4 watt resistor that is involved in the filament string, and that will snap quicker than anything. So I'm not saying, no, you don't need to bring this up on a variac. Admittedly, I don't, but you're a newbie, and I'm trying to tell you the right thing. Yes, you should bring it up on a variac. So, I forget how to turn this on. Oh yeah, I forget the on-off is here. So what I'm going to do is going to bring it up on the variac, and make sure we turn it down all the way first. I'm going to put it on my amps setting, and bring it up. Okay, first of all, I can see it is drawing. But then you see how the needle kind of like dips back down again? If it was shorting, it would just keep on going, or it would start measuring something unusually high. And we're already at 75%, and it's not really drawing that much. So I feel pretty confident. I can just go ahead and bring this up the rest of the way. All right, here it goes. Should be, first of all, let's see if it's lighting up back here. It must be, because it's making noise. Okay, so what just happened there? What just happened is that the set isn't working right. You heard that buzzing noise? Well, that means something has gone wrong. That is very, very common in these sets, especially when they get to be this age. And that's going to be the filter capacitors. All right, so let's just talk about capacitors for a little bit, because you're going to be replacing tons and tons and tons of them if you intend to go into this hobby. I'd say replacing capacitors in these things is probably about equal to people replacing light bulbs and stuff in pinball machines. Then again, someone in the pinball industry, if you're on this video, please inform me what you do the most, because I have no idea. Anyway, there's a pinball museum in town, so kind of dig it. I digress. So here is one of the biggest problems that we have with radios and their relationship to the current or the juice that comes out of our wall outlets. And the problem is that very early on when it came to talking about electrical transmission. Thomas Edison thought, well, we should just make it all DC. And so he would put in these systems DC, but the problem is, like, you couldn't go very far from the generating facility before basically the current would poop out. And so Westinghouse came up with the alternating current system, which is superior. It's great because you can send electricity over very long distances and at the same comparative strength. But what it does is it goes back and forth to the power plant. In the US, it goes back 60 times a second, so 60 cycles. And so that means that the radio, which wants to have a kind of a clean DC signal, instead what it's going to see is this ugly, like, wah coming in. That's literally the noise that you just heard, was the sound of 60 cycle hum interrupting everything. And why is that happening? Because the chances are that beyond that, probably the radio just works fine. The reason is because the capacitors in a particular type of capacitor has gone bad. And they are called electrolytic capacitors. And these guys are the heart of your set's DC system, because without it, the set's not going to work. So how do these work anyway? Well, the way to look at it is, okay, so imagine that we have this nasty AC current coming into the set, and it's going back and forth to the factory 60 times a second. So that means that in the process of clicking back and forth, there's going to be a little bit of a gap. And so what happens is that these little capacitors, you can look at them kind of as a very, very temporary battery. They're going to charge and discharge and charge and discharge and charge and discharge. And they're going to do so 60 times a second. And that will in turn kind of add some little filler to turn this nasty mess coming into the set look maybe something more like this. It's going to smooth it out. It means it's not going to remove all of the hum, but most of it, to where the audio coming in from the radio through the amplifier section will cover up for it. And so what happens is that over time, there is a really tightly wound structure of aluminum foil that has a layer in between all the sheets and a dielectric compound, and it dries out. When it dries out, they stop functioning. They don't charge and discharge anymore. They've essentially, they've leaked completely out. That's one kind of capacitor that's in these things. The other kind of capacitor, we generically in this hobby call them paper caps, and they are essentially much lower in value. And one thing I forgot to mention that's really key with these electrolytics is that they have a polarity. And with the new capacitors, it's almost always going to be this stripe here that's negative. By default, the other side, usually the longer lead too, is positive. And the values are written on the sides. That 33 where it says UF, I'm not sure if that really says U, it's probably a symbol of some sort. 33 microfarads is what it says. And then it says 250 V, that means 250 volts DC. That's how much it can handle as far as voltage. We'll get into that just a little bit. These guys, the paper caps, are not polarized, and they're usually much lower. Like this is a 0.01 microfarad capacitor. It's like many, many, many magnitudes less than that. And they're used in a completely different way in these sets. And they too go leaky, even though most of the time when I replace just the electrolytics, they'll work. But right now the radio is not going to work. So let's take the chassis out, which involves removing these 3 screws underneath. And please make sure it's unplugged from the outlet before you do so. Otherwise you could get shocked, like I could have if I hadn't taken it out of the outlet. Silly me. Alrighty, here is the underside. And where we, as radio restoration people, spend most of our time looking at the bottom of these things, because that's where most of the guts go. And of course they couldn't expose this to the top, because otherwise customers would have stuck their hands in there and electrocuted themselves, which would have been very unfortunate and very expensive for the companies, even though I'm sure they had much laxer safety protocols. But anyway, this has been worked on because obviously it would have not left the factory like this. And the quality of the work is abysmal. Like, look at that. That's bad. And the thing is, what's worse is that this was done by some repair shop. Probably they hired Junior after high school to work on this or something like that, and the old man didn't care anymore because he was hitting the bottle. Anyway, we can correct that problem because these are bad anyway. I've seen these in the past. These are Planet brand capacitors, and it's interesting because this thing was from 1951-53. That must have meant that the original capacitors in it failed pretty quick, because this is old too. I mean, that's probably a little bit newer than the set, but not by much. Guaranteed for 1 year. Well, definitely outlived its 1 year by a long time. Now, I mentioned that. This is the electrolytic capacitor. And most of the time they are marked or color-coded. This one's very clearly marked, which is good for us because it's good for me to demonstrate. You'll see right here on the left-hand side it says 40 plus 30 plus 20. And what that means in this case is that my camera's not focusing right. Okay, here we go. That there's a 40, a 30, and a 20 microfarad capacitor inside. So that means there's 3 of them stuffed inside this single tube, and that their working voltage DC is 150. It'll never see that, but they made them just a little bit higher than that because when you turn these things on, there's a little bit of a surge sometimes. Luckily, the wire is still very bright and legible, and the markings are here: yellow, red, green, black. And that means yellow is 40, 20 is red, 20 is green, and black is the common negative. And where does the common negative go to, by the way? It goes here, because what we want to confirm, and I already know the answer to it because I've worked on this thing a million times, is it a floating or a hot chassis set? Because if this was attached to something that was going to the chassis ground, as in this, if you could trace it to that, then yes, that would be a big problem, and you would have a electrical hazard on your hand. But I know, and it's not really the case for that. Instead, the ground is actually right here, and then the other side goes through this weird coil here. I'm not sure why they did this. And then that goes to that jumper to there. That's our ground. That is the other end of the AC line. And so as a result, and I'm going to talk about this for just a second, that is the most important capacitor in this entire set when it comes to what you should replace and what you should replace it with. Now, why am I stressing that? And the reason I'm stressing it is because, let's see, what is the value that is on this? And sometimes you got to scrape the wax away with your fingernail. I don't know what it is. I think it's beeswax or something, but it says 0.05. So that means it's 0.05 microfarads. Now, granted, someone did their homework back then, because that amount, if that capacitor were guaranteed to be good, would be enough to still give you a jolt, but you're getting closer to what a modern standard would be. That's not what we're going to go for. We're going to reduce that down even further to a level that is below the level of current that can get to a human's heart and basically not cause it to fibrillate, which is a lot lower than what they understood back in these days. Some people have heart conditions, and that can cause their heart to fibrillate a lot easier with a lot less current. And so that had to be reduced. And so we're going to put a 0.01 rated capacitor in the place of this. The rest of these are the aforementioned paper capacitors that I just talked about before, the electrolytics. And they too have their values written on them almost always. And you can see it says 0.05 microfarads, 200 volts, 200 VDC rather. That means volts DC. And it has 2 ends, and again, they're not polarized. So you can replace these one by one until they're all replaced. But, and this is just me, what I tried to do is I start as far back from the power cord as I can. and really far back from the power, really far in, did I say in front or back? I can't remember. Ah, I'm trying to get as close to the power cord as I can. So when the incoming AC happens, what is the first thing it encounters that needs to be replaced? And the most obvious thing is this. This is coming directly off, and the rectifier. And if that doesn't work, ain't nothing behind it going to work. And we know it's bad because it made that noise. And so we have 3 capacitors to replace, and so let me pull out some new ones. Okay, it's pit stop time. We're going to talk about tools a little bit because I realized that too is kind of an important thing when it comes to working on these. And I'm going to just show my equipment, what I use, and these are things that I like. But varying on your budget and also where you live and your access to different brands, that's going to change. I will say I think it's worth it to invest in a nice multimeter. There's a lot of cheap Chinese ones, and I don't necessarily think there's anything wrong with it. But my go-to is a Fluke 115. They're reasonably priced. I've had this for probably 12 years, and I'm rough on my tools. Like, I've dropped this thing. You know, I've probably stepped on it. I don't know what I've done to it, but it's fine, and it's very accurate. And again, I've had it 12 years. I could have brought like I probably could have bought like a dozen Chinese meters for that money, but this is still perfectly good. I like it a lot. I'm a big fan of, now I can't remember the brand name of it, Exolite brand tools. They're very fine hand tools. You know, just having good hand tools just makes all the difference in the world. And I use these very small snippers. Makes it easy to get into like really small spaces. Likewise, I like to use a very small pair of fine needle nose pliers. It makes it good for grabbing. I also use a variety of weird tools like dental tools, like little picks, and also hemostats. Sometimes you can use hemostats to grab wires in really difficult to access places, or you can use them to twist and break leads if you need to. I use also something that I don't think I could live without anymore, because once I started using it, thanks to my friend Andy, if he's watching, thank you, Andy, I can't live without it. And they are Metcal soldering stations. These use induction, and as a result you get this nice little skinny line, and you get this tiny little, like almost cigarette holder type tip. It doesn't look like much, does it? And these are interchangeable. You can, you know, pop these out, and there's many different tips. That thing is lightweight, and it gets into small places, and it melts even the biggest blobs of solder like almost immediately. Next up, when it comes to my variacs and multimeters, I like a lot of things that B&K Precision makes. I know that a lot of people go gaga over Syncor. I don't blame you. I kind of wish I had one too, but the difference is this. This B&K 1655 cost me 120 bucks. The Syncor equivalent, of which I've used at the museum a lot, it's actually my bench unit there, $500 plus. So you be the judge. I've had good luck with this thing. If you're going to work on a lot of this stuff and you want to test the capacitors, especially the ones used in sets with power transformers, then you're going to need a cap checker. And you need something that can actually put out some voltage, because the modern capacitor checkers are usually going to be testing for low voltage stuff. And you really can't accurately deduce what that capacitor's condition is unless you put the real voltage on it was meant to have. So these Sprague Telemike model TO5 capacitor analyzers, they're great. These are pricey. I am borrowing it from the museum because I'm essentially doing all the radios, not all the radios, but a lot of the radios restoration projects. Now lastly, I should have gotten this out before I started working on this. It's a tube tester. Now I have several tube testers, but this by far is my favorite. This is a Hickok TV7. These were made for the US military, and so they cost a pretty penny when they were new, and they're not cheap now. Maybe they've gone down in value, I don't know, but at one point these were close to $1,000 each. But it'll be the last tube tester you ever buy. Everything is built like a tank, literally. All of the socket material is made out of extremely durable material. This is all ceramic. This is mica. It's basically mica infused Bakelite. And you can also get socket savers for these. It does everything that you need. It does everything from the big pin, older style tubes, and then it does, of course, our octals and loctals, even our acorn tubes. And it shows more of an accurate condition of what the tubes might be in. It even comes with a pin straightener. Worth every single penny. I can't recommend these enough. But if you can't afford that, then the B&K, I'm not going to get it out. I haven't had it out in a while. B&K 747s are excellent. They're just a little bit more of a pain in the butt to set up, and they're not as nice a quality, but they're good. All right, so now let's get back to the regularly scheduled program of showing how to work on the radio. So now let's get to work on replacing these messed up electrolytics. And like I said, there's more than one value in there. In fact, there's 3. And since they don't really make this kind of thing anymore, I mean, you can get them on, you can get reproductions on websites, but they cost a fortune, and it's kind of, I don't know, kind of stupid in my opinion, unless you just want that original look. We're going to replace the 3 inside of there with 3 of these electrolytic capacitors. Let's talk about capacitance for just a little bit, and when it comes to what values you replace things with, and how to kind of come up with a rule of thumb. So it says indeed here 40, 20, 20. Is that 40? Is it 30? No, I've been reading this wrong. I'm sorry, guys. 40, 30, and 20. It's 3 completely different values, right? So you think, oh dear, I have to replace it with exactly those values. The answer is no, you really don't have to. When it comes to electrolytic capacitors, the value that replaces needs to be at or greater the capacitance. That doesn't mean go hog wild, like, stick 1,000 microfarad cap in there, because that's not very nice to the rectifier. But, if you don't have a bunch of 20s or 30 microfarad caps sitting around and all you got is, say, I don't know, a bunch of 47 microfarad capacitors, then why not? So these three capacitors here will be replaced with 3 of the same value, 3 47 microfarad caps. Why? Because all of these are either at or greater than the capacitance inside of here. It's not going to hurt anything. In fact, the radio will work a little bit better. And then the black common wire, which is this, that means that all 3 of those wires inside, which represent those capacitors, are tied here, commonly tied together. That's why it says common negative. So that means that we will need to make sure that all the negatives, which are again these little stripes, that they're all stuck together. So all the negatives will be wired together, right? And then what the positives of each one of these, like sticking out, as it'll offer to replace each one of these. Now, part of the challenge here, especially if you're new to this, is kind of looking at these things like a 3D puzzle, which is how I look at them now. And so when I see something like this, I immediately start thinking to myself, where can I stick the new capacitors? There's some people out there who, and I'm not going to fault them for suggesting this, would go out of their way to put in a terminal strip for the new capacitors. But the way I look at it is, well, this set is already full of a lot of quote-unquote terminal strips. It's just a matter of finding one where things will fit and where I can run my leads to. So we know that this is the common negative, right? And so there's lots of opportunities to mount things here. And so, but I also know that this wire probably goes elsewhere, and that elsewhere is actually right here. And that is where we know from what I just said previous is the location of the chassis ground capacitor. So I have 2 different ways of mounting this. But first I'm going to twist the negatives of these 3 capacitors together and kind of do a little bit of a sizing thing. Alright, so here is kind of where getting creative comes in handy. As I mentioned, like there's a kind of a little bit of 3D Jenga going on here, which is, where can I put things? So first of all, I've soldered these negative leads all together. So I've kind of like made a wad of capacitors, and you want to do it real tight together so they're not going to wiggle around that much. Something here that look like the landing ship that Darth Vader brought in Star Wars. I don't know. Anyway, so I've been looking around here and I'm like, well, I could put it here because clearly, wait a minute, clearly that's the negative. But the only thing I don't like about that is that it's right over a tube. But on the other hand, let me look at what kind of tube that is. It's 12SQ7. Okay, well 12SQ7 does not get that hot. It gets warm. If it, on the other hand, was under this one, which is the output tube 50L6, that gets pretty hot. So I think I'd feel a little bit better about putting these in here. Not there. I'm sorry. Yes, I could go here because it jumpers right there. I think before I do that, I want to clear out some room. So I'm going to replace this capacitor. And we can see what it says on it. It says 0.01. I know it's not the easiest thing to see because it's faded a little bit. Again, sometimes if you can't see it that easily, you can like kind of scrape at it with your fingernail a little bit. There, it's more clear now. As far as the voltage is concerned, all of my replacement capacitors are 630 volts, so I don't pay attention to what these say. If it says 200 volts, I'm like, so what? Who cares? Because if it's, again, with these paper capacitor replacements, the voltage needs to be at or greater. If you make it under, then you're going to have a problem because it'll burn them out. 630 volts for 200 volts, not a problem. That's actually better in my opinion. But in order to do so, let me show you just in general how I replace these guys. I got to get a better camera rig. This is some crappy thing I bought on Temu. Anyway, so I'm just going to replace one capacitor here. One that is a little easier to see. So you see how we have another capacitor here. It says 0.05 microfarads. And again, the voltage is not important because I know that the capacitors I have are all at 630 volts and there's nothing in this set that has that high of a voltage rating in it. But, and I still do this, even though I've worked on a million of these radios, you don't want to lose your place. Now granted, you can always get a schematic, but in my opinion, it's easier to just look at your parts, take your time, replace one lead at a time, so you don't lose your place. So I can see here, these have a lead on either end. They are what we would refer to as an axial capacitor. So I'm going to clip one end of the old lead, and I'm going to leave quite a bit of the existing lead on. I'm also going to take off this insulated sleeving, which I'm actually going to reuse. Now here is our replacement capacitor. It says something to the nature of 473K. In modern capacitor language, that means it's a 0.05 rated capacitors. Since I have the old insulation, might as well use it. And because that's quite a bit of a length of lead, I'm going to trim it down a little bit. And the other thing that I do after I trim it is I make a little hook here, kind of like that. That's going to preset this thing up for me to clamp it around part of the old lead, and also to prevent that insulation from falling off. So again, I left quite a bit of my old lead here because I was like, I want to remember where that goes. So now I'm just going to attach my little lead here all the way to the bottom of the old lead. Of course, it's not cooperating. You want to really cinch this up. You want a good mechanical tight connection. I know it's not the prettiest looking thing, but the next part is really critical. Got our solder, or soldering iron, a hot iron. So what you want to do is touch the work first, get it hot, and then just flow the solder in. I mean, kind of like the same principle of good welding. You will just want like a good solid application. And then we're going to clip the excess lead off. Let's see if I can get in so you can see this a little bit closer. My wife isn't suggesting that I get a better camera to do these things. I'm not sure if you can see that, but it doesn't hurt to also like wiggle it, pull and tug on it. See, like it's a good solid connection. And now what we want to do is do exactly the same thing on the other side. See, we have like quite a bit of a long lead here. And so I'm going to clip part of the old capacitor off and throw that away. So now we have that length of lead left. And that's when I can start to kind of see how I can route the capacitor. And here's the thing. Oftentimes they would give a lot of air to these capacitors around the tubes, again, because these things generate some heat. And so you don't want them like that close. And so I'm going to kind of run it on the outer edge of this tube. And you can see that's too long of a lead. And the more you do this, the better you'll get at it, at judging how much lead you need. And so again, I'm going to make a little hook. And then I'm just going to pull this up a little bit. Okay. Of course, it's not behaving because I'm doing this live. Okay, so again, we got like a nice, pretty decent mechanical connection. And then I'll solder that in too. And since I've taken the camera off of the holder, I can't film that, but repeat what I did on the other side. All right, well, after poking and prodding and replacing a few of these capacitors in exactly the same way that I just showed you, change plans. I replaced this one, and I thought, well, our common ground also goes here. So as long as I have my common ground connection, this is a better place because I can just put it in there right like that. It's a good solid connection. Again, like hint, hint, wink, wink. You know, people are like, oh, you have to put in a terminal strip. Well, there's one right there. So I'll use that. So what I'm going to do is kind of like glob this up with a little solder. I'm going to make it like a little seat, and then like we'll attach those negatives together. Well, looky there. They look like 3 peas in a pod. Anyway, you can see we got a real close connection there. It's not going to move. And we have our nice 3 positive leads sticking up here. Now it's just a matter of attaching each of our positive leads to the new positives of the new electrolytics. And this common ground, well, we don't need that anymore. So we can get that out of here. This guy. Adios! So now we have these nice, happy leads here. And I just realized something. These two are not going to reach. See? Not quite. It's not a big deal. We can just make some new ones, but we can at least use this one, even though I guess that soldering job's okay. These other two are garbage solder jobs, so might as well just go ahead and replace them. That's why I keep lots of this stuff around. I have all kinds of different wire. Crap. Anyway, this stuff works pretty good. I like it because it's kind of flexible too. And don't worry about replicating your color codes. It doesn't matter. I mean, they're all the same value anyway. It's just a matter of like running new leads. It's going to reach to each of these positives here. Now let's try this again. First of all, I did replace that pilot lamp. So let's plug it back in. Shouldn't be running these off that pilot lamp if you can help it, by the way, because they are integrated into the filament string, and that's just going to stress out your rectifier tube unnecessarily. So I've got a antenna clip lead, and you know, it may or may not work. Just because the filter capacitors were bad doesn't mean that that was the only problem.
It ain't gonna be Mike Tyson. No one's gonna want to watch.
Well, I guess that answers that question. It does work. Speaking of Mike Tyson, I'm not sure if anyone got a whiff of that, but that's like the stupidest thing ever. Says a lot about the overall situation in this country right now. But anyway, that seems like that works pretty good. This is stuck.
Here's another great
Guiándonos.
Success! It even sounds good. In fact, when I first got this thing, I thought to myself, Audax. That's the brand name. It says Audax. And I thought, I've seen that before. That's a French speaker. And how it wound up in American set, I have no idea. We Americans back in the day were pretty much the China of manufacturing. We could make things cheaper than anybody, so that somehow this got supplied to the French speaker. And I've seen a few of these with that same speaker. I'd love to know the story on that. It probably was that someone had a supply of those things somehow, some way, and got a really cheap deal on it, and so they stuck them in these radios. Because I've seen a few of these Continentals, and I feel like the later ones did not have that. They just had a regular, metal pie pan American speaker. So we're off to a good start, but that's all I'm going to do for this evening because it's getting late. And I want to help my wife with fixing the furniture over there. So we'll continue this tomorrow. We are back. Day number 2 of working on the Helicopters Continental. And we're outside, as you can tell. And the reason is because this thing has a lot of dust bunnies on it. And what I want to do before I go too much further is try to clean the dust bunnies off. And it looks like it's a relatively clean and unrusty, uncorroded chassis, which is good. I found that a leaf blower does a great job of removing most of it. And there we are. Clean as a whistle. I'll take it back inside. And then we can kind of work on freeing up this tuning condenser mechanism, because yesterday it was not moving, probably because the grease that was in it is all solidified. I'll take a little bit of a damp paper towel and clean up the tubes, the metal, that kind of thing. I know a lot of people are like, well, why do you need to do that? You don't need to do it, but I just personally think it looks better. You've got this ancient radio. I'm seeing that, and someone has stuck that rubber washer in there, probably because the original rubber wore out. I think someone restrung it too, but it's stuck, so I'm going to see if I can unstick it. Okay, so you see how much nicer that looks now? It's just a little snazzier looking, and when I took the 12SQ7 out of there, the bottom's broken off of it, and I think I could kind of guess which way it goes. Like, I think the key broke off there. Oh wait, you know what? Someone scratched it right there. I bet it goes there. I'm just going to guess that's the case. You know what I'll do? I'm curious before I do anything. Let me bring it up on the Variac and see if it works or not. I'm just curious. Okay, so nothing blew up. And it works.
Opened the door for them to say, oh, I don't want to hurt you, and I can be...
Anyway, we've got some dirty controls and got some sticky bearings in the tuning condenser, which is this thing with all the fins. Don't ask me how it works. It's basically a giant air capacitor, and it enables your radio to tune through a bunch of hocus pocus magic that I don't understand because I'm not an engineer. But anyway, it does get sticky, and you want to use a real fine oil on the front and the back bearings, because that needs to make a good, nice contact. And like, that's just why I blew all the dust out of there first. It's getting a little tiny bit in the middle there too. Just work that in a little bit. Likewise, we'll just touch up the bearings surfaces a little bit here. And a little bit here, but make sure you don't get any on that pulley surface, otherwise the string will slip. Just let that kind of work its way in, and eventually this will get easier and easier. This is all gummed up too. So what I tend to do is I get like a little piece of cloth or whatever and get a little oil on it. I just want to come up here and get the slider area where the tuning indicator goes. This is pretty gummed up. I'll probably have to clean it up a little bit more. But you'll get the idea. You just want to make that good and slick. And already it's making a big difference. And likewise, we need to clean the band switch, which is this guy right here. And don't do what I'm doing. I'm standing it up against my metal box here. How very smart of me. Anyways, this is all dirty, and so I'm going to use some contact cleaner to remedy that problem. And I'm just going to admit I'm using WD-40. And some people roll their eyes and they'll be like, oh, like you can't use WD-40. I don't know. There's been arguments about it back and forth and back and forth. I use it on all my stuff, including all my stereo equipment. Works just fine for me. So,
KBST, 1310 AM, Oakland, San Francisco.
all right. I'm going to turn it off because it's still got quite a few old capacitors in there, including the original ground cap, which, as I mentioned, is the most important capacitor in this set, because if you leave the original one in there, then, you know, possibility you're going to get jolted in kind of a not nice way. So let's flip it over and continue the recapping job. And then after that, we've got a treat. I'm going to show you how you can actually make these even more useful by adding audio input feature. Sorry, got a frog in my throat today. All right, so I was able to replace that great big capacitor with this little coil around it with one of these across the line capacitors. It's an X2Y2 across the line cap. And why is that important? It's important because if this gets struck by lightning, which is a remote possibility, but it happens, or there's a surge, this is the first line of defense. And if you have a paper cap in there, well, it could fuse together hard, and you would have like a dramatic, you know, true hot chassis, which means everything coming out of the line cords now are going to be able to like come right through the metal into you. With an X2Y2 across the line cap, it'll rupture, it'll like split open, and it'll kill the circuit. That's preferable, you know, instead of like incinerating or fusing together. And it still works just fine.
Especially this time of year with hospitality.
Hi, yeah, this is a question. I want to...
All right, seems like it's working pretty good. Not done yet. We have two more capacitors to replace. We have this one. It's a 0.01 rated, 0.1 rated capacitor, and then this guy, which if I unplug it, I can twist it around. It's probably not much. I'm guessing it's probably 0.05 or something like that. Yeah, 0.05 microfarads. These two need to be replaced. Then, as far as the radio is concerned, it'll be done. But then, as I said previously, we're going to add an audio input feature will allow you to listen to music or whatever you want to listen to. Okay, so let's talk a little bit about adding audio input abilities to one of these radios. So I did mention very early on in this video that these are generically known as hot chassis sets, or in this case a floating chassis set, meaning there's a potential for current to get to the human body if you touch this, even though at this point it's pretty small. We want to make sure that that's absolutely the case when we add our audio input cable, because if you think about it, your 3.5 millimeter stereo jack, or whatever you use to put into the audio, is going to be connecting basically to the chassis. And so we want to make sure that we put a little bit of a barrier between the user and the chassis. So we're going to put one of these in. And this is going to be functioning as what we call an isolation transformer. It's kind of like the same as that big bad boy up there, much smaller package. And if I were to describe electrically what this is, it's just like a wall wart. So it has a primary and a secondary, these two fat pins that are spread apart. Well, the pins that are spread apart the most, those are the primary. That would have been where the 120 volts would have come in if this were a wall wart. And the secondary are these guys, and what comes out of that is 12 volts. We buy these simple transformers in bulk from China. I don't know what they were used for originally, but they're cheap. And so what we're going to do is run our... Why is this not focusing? stupid at using these cameras. Anyway, we're going to run the audio through this, and I'm going to show you how that is done. And I happen to draw a little diagram here, so let's kind of take a look at it. Okay, so we're going to talk about the volume control just a little bit, which is on this radio, this guy, which is unfortunately kind of buried in there. You see that little barrel-shaped thing? Well, here's the barrel. Here's the shaft where you attach the knob to make it go up and down. And coming off of the back of this thing is going to be 3 legs. There's two that are coming basically kind of in the center of this drum, and that's the power cords. I'm talking about there's going to be these little brass or thin metal tabs, and essentially what they are is the input for the volume control, because basically the volume control is going to act like a big resistor, and it's going to either allow more or less signal to get through it. And so we call the top of the volume control the radio signal side, or the positive. So this is where your signal that has been generated by the rest of the radios coming in, and this is your ability to like increase or decrease its volume. And then on the other side is the bottom of the pot, which is the negative. So what we want to do is we want to run our incoming audio into the top, which is here, of the volume control. But as I mentioned, we need to put our isolation transformer in there. So remember I just showed you this thing? Well, that's what that is. And what we're going to do is, here's our 3.5 millimeter stereo cable. In fact, let me see if I have one of those, just that I can, not sure if you can see this, it's in this package, these guys. So we'll have one of these coming in. We have our right and left channels, the stereo cable, right? Obviously this is not a stereo radio. So what we want to do is for our right and left channels coming out of the audio, we'll have a pair of 30 ohm resistors. Then those tie together, and that goes to your secondary side, which is little skinny pins, or the 6-volt side, or 12-volt side rather, of the transformer. Coming out the other side is going to be, coming out of the primary, is going to be our bottom negative, which goes to the bottom of the volume control. But then coming off of what we will attach to the positive is we have a 0.05 rated microfarad cap, and then we have a 250K resistor. And that is going to create like a little bit of a shunt here, so that this thing here, this which stays in the circuit, isn't going to interfere with the radio reception or performance. So that goes to the top of the volume control. But we also want to make sure that we can turn the radio signal off and on. And so that's where this comes into play. We know that the top of the volume control is where the radio signal comes in. So we'll just like temporarily splice that wire, and at the other end we'll have a little switch, and that'll come out the back of the radio. That'll turn the radio signal on and off. So that's kind of it in a nutshell. And if you want, I'll pause here and you can take a snapshot. So what we'll do is I'm going to put that into physical form. But what I need to do first before I get started is determine which lead coming off the volume control is the top, meaning the incoming radio signal. And I've worked on these before. I know that this shielded cable right here, you see this braided stuff, that is the shielded cable coming off the volume control. I think red is the top of the volume control. That makes sense to me. Let me see where that attaches to. You can see positive goes to, this red wire goes to this RF transformer, which would make sense as the radio signal, which is also associated with the 12S. Is that the Q7? Yeah, 12S Q7. So that seems like a logical conclusion. So I'll clip that. We'll see if the radio continues to work. If it doesn't, we know we've clipped that wire properly. And then we're going to run, we're going to manufacture this components here to this isolation transformer, and then we'll kind of do an installation process. Okay, so I clipped that little red wire. And all I get is a little bit of a hum. You know, if I try to tune the station, I get nothing. So that tells me that's our signal there. And so that's also where we're probably going to want to run our audio. Actually, the audio will need to go through that. Boy, it's pretty sensitive in there. Anyway, let's go ahead and manufacture the components here, and then we'll do a test installation. Okay, so here is our little system here. It's basically replicating what we just saw. Of course, all the cars just had to start up on my block right when I started filming. Anyway, this is essentially where we're at. We have the secondary side here, and this has our two resistors stuck together. That's our right and left channels. And then on our primary side, we have a 0.05 rated ceramic cap here with a 250K resistor, and then this brown wire will go to the top of the volume control, and the negative, which is the black, will go to the other side, or chassis. What I need to do before that is I need to drill a hole in the chassis so that I can put another rubber grommet so that we can run the audio cable through, because you don't want to just drill a hole and run the cable through, because if someone yanks on it, it'll like cut the cord, then you'll have a safety problem again. So again, you got to think about this carefully. So I'm going to turn this right side up, and I'm put a little clamp on it so I can hold it tightly and then drill a hole. Okay, so we have the system installed, and eventually I put a little glue here so that when this knot will stay put and it won't wiggle around. Alright, so now we're running it through to the volume control, and the other side's going the chassis ground, because again we're going through an isolation transformer, so we can do magic things like that. So let's coming through this Bluetooth. That is my streaming service. I want to see what it sounds like with YouTube coming through. I feel like sometimes the audio is better on YouTube. Alright, so we have it all installed as I showed. I have a little switch here that kills our radio signal, but I've got this little Bluetooth thingy running through, and you can go buy these for about 10 or 15 bucks. Just look up wireless Bluetooth receiver, and they charge up in about 10 minutes. Anyway, I'm playing my phone through that. You see we got good clean audio. A little bit too loud there, but anyway. But I can subsequently unplug that and then get a radio.
Register now.
This is Tim Ray from Trending with Tim Ray. Wednesday, I'll be joined by Sal DiStefano. He is one of the top fitness trainers.
That seems like it is
fitness gurus right now.
on the bleeding edge of oscillating. I wonder if I need to add more capacitance here.
Also,
by the way, what I'm about to do not do what I'm about to do, period. But I'm going to do this anyway. And again, don't do this at home.
6 p.m. Central on Relevant Radio.
Thanks to our sponsor, the Knights of Columbus, the premier lay Catholic organization for men guided by the principles of charity, unity, fraternity, and patriotism. As a fellow Knight, I invite you to consider joining the Knights of Columbus.
Oh, I don't want to hear that crap. Anyway, yeah, I think what we need to do is add one more safety cap. Like I said, we usually start off with a 0.01 rated capacitor. You can probably put another couple in there. You can get up to like around 0.03 microfarads. You're fine. But the radio portion is just oscillating because, again, we started off with a 0.05 rated capacitor, and now we've got like a 0.01 rated capacitor. So we're going to double that up a little bit. That'll probably get rid of that squealing on the upper end of the radio dial.
So we're pulling together our team. We've
Okay, that's
started to
better.
hire our
That's cleaner.
directors. And that our directors that are hiring all of our associates
Everything, and I just knew.
You gotta figure out, no, you can't. Of hundreds of thousands of people.
Okay, so that sounds pretty good. Let's put it back on Bluetooth and see if it still sounds good, which it should. Probably sound better, actually. Let's see, is it still got radio going through?
If you would let me spend my whole life loving you, life could be a dream, sweetheart. Now,
It'll sound better when you put it back in the cabinet. The cabinet will resonate a little bit, but that still doesn't sound that bad, really. It's got a nice, clean sound. I can tell you, man, those French speakers, them's good speakers. I know it's French because I can see it right there. It says, clearly must say, see that? Crap. Why is this not light up shining on this the way I want it to? See, it says France right there. So, last thing I do electrically is I'm not real happy with this cord. It would probably be okay, but I'm gonna do a little test here. Okay, see I bent that over and it kind of started cracking a little bit, and it also doesn't it's not springing back. It's because the rubber on this is hardened, and it's just going to get worse, and eventually it's not going to be usable. So if you fully electrically overhaul one of these guys and say that someone is very happy with it and they use it every day for years and years, well, one day that cord surely is going to fail, and it's closer to failing. So let's go ahead and replace it with a nice newer cord. I have these little things here, and I know there's some special tool that installs them, but I don't have them. I use usually a screwdriver, like a flat-headed screwdriver, and a hammer. I just kind of like tap it out. But first, what you want to do is you want to cut the cord, and that way it'll pull out. Alright, so I got that new cord installed. Wound up finding a old white lamp cord, so I just put that on there. That's fine. But as far as the radio goes, whoops, I'm not sure why I did that. I cleaned the cabinet. Now this has the unusual matte black finish. Almost, I guess it's not even black, it's like charcoal. So I wanted to preserve as much of that as possible. It's not perfect, it's been used. Likewise, what I do, if you want to clean the knobs, don't do this to Bakelite knobs. If they're just regular plastic knobs, get a little ammonia and some warm water, and that'll get rid of all the nasty finger grease off of them and clean them up. And so now it's time to reunite everything together. All right. I think that looks pretty good. Kind of a badass looking radio, really. I don't know. Anyway, put the back on. And so I can turn it to radio. Let's gotta unplug this. Let's see. Oh yeah, there's no antenna attached. I forgot. These things, like, you have to have an antenna screwed here. And I'll admit, most of the people that buy these things from us don't listen to the actual AM radio at all. They just listen to their music. But let me get the antenna just to prove, yes, the radio works, so that we can conclude this episode.
% of your investment being deductible for 2024. Don't miss out on this limit. Create monthly.
It's actually a benefit to take the extra rent. Migrantes estaban trayendo with the Rams all those years. Fred Taylor.
Affordable, reliable.
Every business faces challenges, but shipping shouldn't. You're seeing the hardest hit areas in the Bay Area.
All right, so the radio works too. Voila! So, anyway, I've been trying to make these episodes, and I found that it's a lot more difficult to explain every little thing. And I know I left a ton of stuff out of this episode too. Let me know if you guys want to see more of this kind of thing, or if you're new, did this help you? I tried to slow down, and let me tell you, the first couple are always going to be the most difficult. Don't, you know, if you don't know what you're doing, try to get some help. There's a lot of resources online. Some of you who are watching are actually on some of those online resources, like the Antique Radio Forum, and there's also tons of videos like mine, including many that are a lot better, because I'm not exactly the most technical person, but I've just, I've restored enough of these where they're kind of like I can like almost do them in my sleep at this point. So I was trying just to remember what it was like when I first started and how I was able to kind of understand it. But let me know in the comments, and I'll see what I can do about getting another episode together at some point that maybe goes into even more detail. But until that happens, I'll see you guys next time. All right, see you later. Bye.